Studies Section 3, Theory of Regression Analysis. Introduction. This section will introduce to you the evolution of regression as tool for statistical and econometric analysis. We will also explore concepts that are applicable to regression analysis. Learning outcomes. When you have studied this section, you should be able to interpret regression analysis, point out the sources of econometric data, interpretation of regression. It was Francis Galton that introduced the term regression in his famous paper titled Family Likeness in Stature in 1886. In this paper, he found that although there was a likelihood for tall parents to have tall children and for short parents to have short children, however, the average height for children born of parents of a given height tended to move or regress along the average height in the population as a whole. That is, children's height from unusual tall or short parents tend to move toward the population's average height. This is known as Galton's law of universal regression. The modern interpretation of regression analysis is quite different, and the regression analysis is said to be concerned with the study of a variable, or more known as explanatory variables, that tends to influence or determine the behavior or action of another variable called dependent variable. This is in order to estimate and or predict the population mean or average value of the dependent variable in terms of the known or fixed in repeated sampling value of the explanatory variables. For example, Galton was interested in knowing why there was stability in the distinction of the population height. In the modern view, the concern is not in the explanation but to know why the average height of sons changes given their father's height. That is, predicting the average height of sons knowing the height of their fathers. Example 2. An economist may be interested in studying the influence of disposable personal income or personal consumption. This kind of analysis will be helpful in estimating the marginal propensity to consume, MPC, that is, the average change in consumption expenditure for a naira worth of change in disposable income. Statistics versus deterministic relationships. Statistical relationships among variables essentially indicate the randomness or stochastic level of the variables. That is, it shows the extent of the probability distribution in the variables. For instance, the regression analysis is concerned with the statistical relationships. However, in the deterministic relationships, we also deal with variables, but these are not stochastic or random as it could be found in the statistical relationships. The dependence of consumption on income, taste, fashion, population, and tax, for example, is statistical in nature. This is in the sense that the explanatory variables, although they are important in determining the level of consumption, will still not enable the consumer to predict his or her consumption exactly due to the fact that there might be some errors that are involved in measuring these variables, as well as a host of other variables that collectively affect the level of consumption but may be difficult to identify individually. Thus, there will be some intrinsic or random variability in the dependent variable consumption that cannot be fully explained, no matter the number of explanatory variables that are put into consideration. Furthermore, in the deterministic situations, we are confronted with the relationship of the type Newton's law of gravity, which states that every particle in the universe attracts every other particle with a force directly proportionate to the product of their masses and inversely proportional to the square of the distance between them. In this context, We are concerned in the deterministic relationships. However, if there are measurement errors, say in the Newton's law of gravity, the otherwise deterministic relationship will become a statistical relationship, and the dependent variable in the Newton's law of gravity, which is the force, will then become a random variable. Regression versus causation. As it could be seen earlier that regression analysis deals with the way one variable depends on other variables, but this does not necessarily indicate causation. According to Kendall and Stewart, 1961, the statistical relationship, however strong and suggestive, cannot establish causal connection. The ideas of causation must be derived from outside statistics, which is ultimately from some theories. In our example of consumption, there is no statistical reason to assume that population does not depend on consumption. The fact that we treat consumption as dependent on population and other explanatory variables is due to non-statistical considerations. Ordinarily, it suggests that the relationship cannot be reversed because we cannot control population by varying consumption. What we should understand here is that the statistical relationship itself cannot guarantee or logically imply causation. To give the causal effect, we must appeal to a priori or theoretical considerations. Newton's law of gravity is symbolized as F is equal to K m1 m2 over r squared, where F is the force, m1 and m2 are the masses, r is the distance, and K is a constant. Regression versus correlation. Conceptually, regression analysis is different from correlation analysis, although they are closely related. The aim of correlation analysis is to measure the degree of association between variables irrespective of whether they are dependent or explanatory variables, while the regression analysis shows the effect of explanatory variables on the dependent variable. For example, we may want to know the correlation between smoking and lung cancer, or between cold and sore throat. Also, we may be interested to know the effects of low salaries and corruption. In regression analysis, emphasis is not on the measure of the degree value of a variable in the basis of the fixed values of other variables. The fundamental difference between regression and correlation is that there is an asymmetry in the way the dependent and explanatory variables are treated in the regression analysis. In the regression analysis, the dependent variable is assumed stochastic, random, or statistical, which means that it has a probability distribution, while the explanatory variables are used to have fixed values. However, in correlation analysis, variables are assumed to be symmetrical, that is, there is no difference between dependent and explanatory variables. This means that the correlation between smoking and lung cancer is the same as that between lung cancer and smoking. Thus, both variables are assumed to be random. Tip: the aim of correlation analysis is to measure the degree of association between variables irrespective of whether they are dependent or explanatory variables, while the regression analysis shows the effect of explanatory variables on the dependent variable. Nature and sources of data for econometric analysis. It is vital to know the nature and sources of data that are often used in any econometric analysis. The sources or otherwise of any econometric analysis depends largely on the availability of the appropriate data. It is therefore important to know the various economic data that could be used in econometric analysis. Types of data. The following are the data that are used in empirical analysis. They are cross-sectional, time series, and pooled, a combination of time series and cross-sectional data. Cross-sectional data. These are data that are collected from different observations of variables at the same point in time, such as population census, survey of the household, etc. Cross-sectional data cover many observations at the same point in time. The problem that one can confront in using this kind of data is the problem of heterogeneity. In Nigeria's population census of 2006, we have some states like Lagos and Kano that are densely populated, and states like Ekiti and Kebbi that are thinly populated. If we include heterogeneous units in the statistical analysis, the size and scale effect must be taken into account so as not to mix apples with oranges. Time series data. The time series data can be said to be the set of observations on the values that a variable takes at different times. This kind of data can be obtained at regular time intervals, such as daily, e.g., stocks prices, weekly, e.g., money supply figures, monthly, government expenditure, consumer price index, quarterly, e.g., foreign direct investment, debts, annually, e.g., gross domestic products. These data that are collected may be quantitative, e.g., income investment expenditure, or qualitative, e.g., male or female, skilled or unskilled workers, male or female. Qualitative variables are also called dummy variables or categorical variables and can be every bit as important as the quantitative variables. There are problems associated with the use of time series data despite the fact that it is commonly used in econometric analysis. One of the problems is that most of the empirical studies on time series stationarity simply means that the mean value of a time series as well as its variance do not vary systematically over time. Data on Table 1 are good examples of time series data. Pooled data. The pooled data comprises both the time series and cross-sectional data. For example, we can observe, say, 50 observations of variables at different periods of time. Thus, the combinations of all the periods observation gives the pooled data. There is a special type of pooled data called panel on longitudinal data. This is a situation where the same cross-sectional unit is surveyed over time. For example, the National Bureau of Statistics (NBS) carries out survey of direction of trade in Nigeria at periodic intervals. At each periodic survey, the same product export/import is valued to find out if there has been any change in the direction of trade in Nigeria since the last survey. By checking and updating the direction of trade periodically, the panel data provide very useful information on the dynamics of the direction of trade. Source of data. There are many sources from which one can get data that will be used for econometric analysis. The sources of data are the places with which we can obtain both quantitative and qualitative data. In Nigeria, data can be obtained from Central Bank of Nigeria, CBN, National Bureau of Statistics, NBS, National Population Commission, NPC, and other government ministries, departments, and agencies. Data can also be obtained from International Monetary Fund, IMF, the World Bank, all United Nations agencies, and countries across the globe. various research centers in the universities all over the world, etc. Study section summary. In this study section, you learn that regressional analysis deals with the study of a variable or more, known as explanatory variables, that tends to influence or determine the behavior or action of another variable called dependent variable. Also, you learn the nature and sources of data for econometric analysis. This is the end of study section 3. Thanks for listening.